Hello. Previously I talked about how to use the Hough Transform to detect the lines, and I explained that for the AB space using the slope-intercept form of a line in the image. Now this is not used in practice, and I'm going to explain why, but first I have to tell you that even if it's not explained in practice, I talked about that technique because the method of voting is is the same actually in the practical method. Okay, it's in fact easier to understand it for the AB space. Now, why this method, why the slope-intercept form of the line is not practical? So there are many reasons, and the major one is this. So this is our image. This is the x-axis and this is the y-axis. Now, when I have a line like this one, its slope is given by A. Let's denote it A1. Now, a line that has a higher slope is this one. Okay, this is A2, and A2 is higher than A1. Now, as I increase the slope, I tend to get a line that is vertical, and when the line gets exactly vertical, so like this one, let's say that this line is vertical, then A approaches infinity, and this cannot be implemented on a computer. So this is the main problem with the Hough transform using the slope intercept form of the line. So this is not used in practice. So what we do use is another representation. So let's say that I have an image, okay, and I have a line like this one. So to represent this line, we use rather something called polar coordinates, and I'm going to explain that in a moment. So there are of course two parameters like this representation. So in this representation I have, for this representation of the line, I have two parameters. The first is A, the slope, and the second is B, the intercept. So here in this case also I have two parameters. So the first is the distance from the origin that is normal to the line. So here I have a perpendicular line. So let's call this one the normal, just for notation. So this normal is actually a distance, right? So and this distance is evaluated from here, the origin, to the point where that normal is perpendicular. So it has to be perpendicular, otherwise this is wrong. So this distance is given by rho and sometimes d. Okay, and the second parameter is theta, and is the angle measured from x, from this axis here, okay, to the normal. So it is given by this angle. So we always start this theta from the x-axis to the normal. Now we have to fix, of course, a direction for theta where it is positive. Okay, so the theta is positive in this direction. Therefore, I would get an angle that is positive. So that's the new representation. It is the theta and rho parameters. So this is theta and this is rho. I think that I probably denoted this as theta, but this is rho. Okay. Now, how to represent that mathematically? So this representation mathematically is given by rho equal x cosine of theta plus y sine of theta. So what does this mean is that all the points that have the coordinates x and y along that line satisfy this equation. Okay, I'm going to repeat that again. So all the points along this line that have coordinates x and y satisfy this equation. So let's say, for example, that I have an edge point here that has coordinates x0, y0, right? So the following line that has this rho and this theta satisfies this equation. And of course, as I said earlier, all the points, not only x0, y0, all the points on this line satisfy this equation. So this is called polar representation of a line. And I'm going to explain later, of course, why this does not have problems in for vertical lines like this one. Okay. So now let's discuss the range of theta. So to discuss that range, I prepared myself some examples here. So let's take a look at these two examples, and then we will look at these two examples because these two are similar in something, and these two are also similar in something. So what is this thing? So first, here, in this case, I have a line, okay? So I start calculating, evaluating theta from this x-axis to the normal. This is the normal, as I said. This is the normal. So theta here is, of course, included from 0 to 90, okay? In fact, theta in this case is of course smaller than 90, but it can reach a value of 180. So this is another example of theta 2, okay? And of course you can see that it is higher than 90. So and as I said, in fact, theta can take a value from 0 to 180. But in this case, instead of saying that theta is higher than 180, so instead of saying that theta is this one, okay, theta is this angle, what I do is I say, okay, I start calculating again theta from the negative side of the x-axis. I start calculating theta or evaluating theta from the negative side of the x-axis, but then I say that rho is negative. Okay, again, here in this case, I have a theta that is evaluated from the same axis, of course, but from the negative side of the x-axis, and I evaluate my theta and I say that my rho is negative. So in this case, rho is positive, okay, and theta is evaluated from the positive side of this axis, and it can reach a range of 180, from 0 to 180. Whereas in this situation, my rho is negative, but my theta is evaluated on the same axis, of course, from the x-axis, but from the negative side. Okay, so this usually happens, this case happens when the normal is below the origin. So in this case and in this case, rho is positive because it is below the origin. So this is the origin and the normal is below it. This is the origin and the normal is below it. So whenever the normal is below the origin, it is positive, and we evaluate theta from the positive side of the x-axis. Whereas in this case, when the rho is above the origin, like in this case and in this case, we say that rho is negative and theta is evaluated on the same axis, of course, on x-axis, but on the negative side. So this is an explanation just to summarize what I just said about the range of theta and the sign of rho. So as I said, if rho is, or if the normal is below the origin, so this is the origin and this is everything below the origin, I have rho that is positive, and theta, of course, belongs to this range, but it is evaluated from this side to this direction. Whereas in this case, if the normal is above the origin, then the rho is considered negative and the theta is, of course, in the same range, but we start from here instead of here. So this means that the range of my theta is going to be included in 0, 180 degrees. Now what about the range of rho? So the range of rho is given by plus or minus square root of 2 multiplied by d, 2 plus square root of 2 multiplied by d. So what is d? D is just the distance between corners of the image. I have an image like this one, so this is the distance d.